Hi, my name is Brandon Williams, and I'll be discussing the daily case study on the mini case study of the daily coffee sales analysis. And I'm not going to go over the questions since they're already written out. So I'll start with A. And A is asking what is the probability that the sample mean daily sales revenue will be more than $530. So the population mean is 520. That's the daily sales. The sample error is $60, and that's the standard deviation over 100 days, which is the sample size, and 6 is the standard deviation. Um, the standard error equals the sigma over the square root of n, which is 60 over the square root of 100, giving 60 over 10, which equals to 6. Um, and it's saying the smaller the standard error, the more the average will be stable. So 6 is a good thing because it's considered a low number. On the Z table, we're going to take $530. We're going to subtract that by the mean of 520 and divide that by the standard deviation of 6. And we get a Z score of 1.67. And that's the area to the left of 1.67. That is 0.9525. That's the area on the left side. And so the probability that the z-score is more than 1.67 is 0.9525. Um, to find that probability, since it asks for a greater value than 530, we're going to subtract it by 1. And when we do that, we get 0.0475. For B, what is the probability that the sample mean daily sales revenue will be less than 515? First, we're going to find the standardized value, and that's the Z table. We're going to take 515, subtract the mean, and divide that by the standard deviation of 6, and we come with the Z score of negative 0.83, and that's below the mean. And we use this to find the area to the left. 0.83 is the standardized value, the Z score. And the question asks, what is the probability saying? And it's saying there's a 20.23% chance that the average daily sales over 100 days will be less than $515, or that a value falls below a z score of negative 3.83. I'm sorry, negative 0.83. And so the probability that z is less than negative 0.83 is 0.2023, and that's the area to the left. And $5 below the mean is not rare, but it's not common either. For C, what is the probability that the sample mean daily sales revenue will be between 510 and 535? And this is when I convert both sample means to Z scores. So I start with 510 and I subtract that by 520, divide that by the standard deviation, and got negative 1.67. That's below the mean. And this is where you'll find the area to the left. And so the probability that the z-score is less than negative 1.67 is 0.0.475. And for the other one, 535 minus the mean of 520 divided by the standard deviation of 6, you get 2.50. That's above the mean. And we use this to find the area to the left. So the probability that the z-score is less than 2.50 is 0.9938. And so we're looking to find the areas between the two. So we're going to subtract the 0.9938 minus 0.0475, and that'll give you 0.9463, which is considered stable, most stable. For D, was the probability that the sample mean daily sales revenue would be at least 525. We're going to take 525 minus the mean, and we're going to divide that by the standard deviation of 6, and we're going to have 0.83 as a standard deviation above the mean. We're going to use this to find the error area on the left. So the probability that the sample mean is less than or equal to 525 is 0.7977. And so this is the left side. We want the right side. So what we're going to do, we're going to subtract that by 1. And we get 0.2023. I'm sorry. Again, that's 0.2023. Okay. So for the first question, it asks if management sets a performance benchmark of $530 per day, how realistic is it to expect the 100-day average to exceed the level? And it's not realistic because there's only a 4.78% chance that the average daily sales revenue over 100 days will be more than $530. Then it asks, explain what the probability implies about typical performance. Um, the average is 520. $530 is setting it higher than typical performance. So, in other words, this is just an above the average performance, and $10 above is not uncommon. Next question is suppose operating costs require average daily sales of at least $515 to maintain profitability. Based on your results, how concerned should the owner be about the revenue risk? Um, with that, it should be low concern because there's only a 20.23% chance of daily sales to drop below 515. So it's low concern. However, you should be aware. $5 below is sometimes, but not constantly. The next question is the owner is considering a marketing promotion designed to increase average daily sales based on your profitability, but based on your probability findings. Does current performance appear stable or volatile? Volatile, I believe that's how you say it. Um, would small improvements in the average sale meaningfully change outcomes? Explain your reasoning using statistical logic rather than intuition. And the current performance is fairly stable in averaging 100 days. The sample mean is between 510 and 535 dollars. The average will fall within this range. Um, the average will fall within this range, and it's 94.63% of the time. 94.63% of the time. And for that second question, not really. There's no guarantee when the probability that the sample means is at least 525 and at 20.23%. So there's an increase, but it wouldn't be often. For the next question, explain why is it appropriate to use normal distribution in this scenario. Be specific about the role of sample size and what distribution is being modeled. Because the sample size is large, it's over 30. So in this case, it's 100. It satisfied the central limit theorem, which you take the large sample of from when you take the large sample from any population, the distribution will be normal. Um, so that's all I have for this.